Hi guys, this is part 2 of the instructional video for 9.1 for balancing chemical equations. So in the last video, I just showed you how to do a regular equation. Now I'm going to show you how to do polyatomic and a combustion, and I'll show you what each of those are. So here's what you would do, okay? If you have a polyatomic that appears on both sides of the equation, you can balance those together. And it will make your life so much easier if you do, okay? Do you remember all those polyatomics that I made you guys memorize? So NO3, NO2, whoops, let me go back to that. PO3, PO4, OH, all of those guys. Anything that you guys can. And it'll be easy to see because I'll show you. So let me pull out my pen. You're going to balance it like normal, okay? Except that I see that I've got NO3 here and NO3 here, okay? It has to be identical. You can't have NO2 on one side and NO3 on the other and say that you're going to balance those together. You can't do that. It doesn't work. All right, so I've got AG. I've got NO3s. Instead of that's terrible. Instead of breaking them apart, I can just balance them as a whole, and it really saves me a lot of time and headache. And then I have MGs, and I've got CLs, and I'm going to do the exact same order on this side. AG, NO3, MG, and CL. All right, I've got one of these. I have one NO3 because this one is not in parentheses. I have one MG, and I've got two CLs on the left. Over here, I have one AG. This one I have two NO3s because there's a 2 on the outside of those parentheses. So there's two of those. There's only one MG because that 2 only goes for what's inside the parentheses. And then there's one CL. All right, so AGs are good, NO3s are not, MGs and CLs. Okay. When you do this, I would balance your polyatomics first. So if I need two NO3s, because there's 2 on the right, then I'm going to make myself have 2 on the left by putting a 2 here. I now have the 2 NO3s that I want. I also have 2 AGs. Okay? Let's see. What do I want to change now? Let's change our AGs. So if I have 2 on the left, now let's make it so I have 2 on the right. I can put a 2 there. And now I have 2 AGs. It's also changed how many CLs I have. So now I have 2 CLs. So let's go back and forth. So I've got 2 and 2, 2 and 2, 1 and 1, and 2 and 2. Okay? Balanced. So in Canvas, you would put a 2 for this guy. You would put a 1 for this guy. You would put a 2 and a 1. And you'd balance that like, oh my goodness. Okay. Let's try one more. Okay? So here, the polyatomic is OH. It has to be OH. You can't have water. That's not the same thing. All right? So I'm going to draw the line. I've got Na, I've got OHs, I've got CAs, and I've got BRs. Again, same order. Na, OHs, CAs, and BRs. All right, I've got one of these. I have one OH because it's not even in parentheses. I've got one CA and I've got 2 BRs. Over here, I have one Na. I have 2 OHs. I've got one CA. That 2 does not go for the calcium. Whoops, and yet I wrote it anyway. Okay, and one BR. So again, I'm going to fix my polyatomics first. I have 2 on the right, so the only thing I can do is put a 2 here. So now I have the 2 OHs I want. It also gives me 2 NAs. That's fine. I'm going to go over and balance my NAs. So if I need 2 on the right, the only thing I can do is put a 2 in front of it. It also changes my BRs. And so let's see, I've got 2 and 2, 2 and 2, 1 and 1, and 2 and 2. Done for that one. Okay, I'm not going to balance this one. However, I will show you, you know what, let's just do it for fun. Okay, I've got H's, I've got, that's not a B. I've got PO4s. I did it again. PO4, I've got Ks. I've got, now notice that I have OHs on this side, but I do not have OHs on this side. So I cannot balance that as a group. Okay, you can't suddenly make this into OH. So I'm going to break this apart and say that's an O, and then I'm going to add that H into this. Okay, so that means that I've got 3 H's here, and I have 1 H here. So 3 plus 1 gives me 4 H's. Don't forget to combine them, okay, because it's still an H. I have 1 PO4, I have 1 K, and I have 1 free oxygen. Don't try to add those oxygens into this because I'm balancing it as part of my PO4. All right, I'm going to write the exact same order on the right. PO4, K, and O. So H's, I have 2 H's here. I don't have any other source of H's here, so I'm going to write a 2 here. I only have 1 PO4 again. This time I have 3 K's. And for oxygens, just the 1, because I'm not going to try to add this in when it's already right there. Okay. So let's see. My polyatomics are already balanced. So let's pick something else. Let's pick K's. Okay, I don't want to mess with my H's right now because there are 2 sources of H's on this side. So let's change our K's first. So I have 3 on the right. The only thing I can do is put a 3 on the left. So now my K is good. So now let's retally my oxygens. I now have 3 free oxygens. And how many H's do I have? Well, I've got still the 3 here. And now I have 3 here on the right because 3 times an invisible 1. So 3 plus 3 gives me 6 oxygens. Don't try to add it onto the 4. You're completely retallying. Okay, I had 4 before. Now I have 6. Okay, so let's see. My K's are good, not my oxygens. Let's change oxygens. So if I have 3 on the left, I need to have 3 on the right. So the only thing I can do is put a 3 here. So now my oxygens are good. I have 3 of those. And now let's see how many H's I have. 3 times 2, I have 6. So let's check. I've got 6 and 6, 1 and 1, 3 and 3, and 3 and 3. So this one's balanced. So in Canvas, you would put a 1 for this one, a 3 for this one, a 1 for this one, and a 3 for this one. I'm going to just show you what we would be balancing here. This is your CO3 and your CO3 here. So you have 1 CO3 on the left and 1 CO3 on the right. Again, there is an OH on the left, but there is no OH on the right, so you're going to have to split that guy up. See if you guys can try and balance that one on your own. All right, now let's talk about combustion equations, okay? What is a combustion equation? I'll show you in the next slide, okay? But once you see a combustion equation, you have to balance it in this order. Carbon, then hydrogen, then oxygen, okay? CH, then O. Also, you're going to want to review this slide again, okay? This is called the odd oxygen rule. So what that means is if you end up with an odd number of oxygens on the right, you need to use that number as the coefficient on the left and multiply all other coefficients by 2. You might need to rewind and hear that one again. I will show you how you do that. So these two are examples of combustion equations. You have some type of hydrocarbon with carbons, hydrogens, or carbons, hydrogens, and oxygens, and then it has to have plus O2, and then it yields CO2 and H2O. So plus O2, CO2, and H2O. This is a combustion equation, okay? You're going to balance it like normal, but again, I'm going to do C, then H, then O, C, then H, then O. All right, so on the left, I've got 2 carbons, I've got 6 hydrogens, and I've got 2 oxygens. On the right, I have 1, 2, 3. All right, I'm going to balance my carbons first. I need to put a 2 here because I need to have 2 carbons. I'm not going to retally my oxygens yet. It's a waste of my time because it's about to change. Let's change my hydrogens. I have 6 on the left. What times 2 will give me 6? 3. So now I have 6 hydrogens. All right, now let's figure out how many oxygens I have on the right. So I have 2 times 2, which is 4 here. I have 4 right there, plus I have 3 times 1 here. So I've got 3 here. So 4 plus 3 is 7. So now this is the odd oxygen rule. So this is how it works. So see how on the right I have an odd number of oxygens? So what you do is you take this number and you plop it right here in front of the O2. Okay? Now I'm going to circle it so that you remember not to touch it for what I'm about to do. So again, you take that odd number, you plop it in front of the O2. The last step is you double all the other coefficients. So if there is no coefficient, it's an invisible 1, and 1 times 2 is 2. For this one, 2 times this 2 is 4, and 2 times this 3 is 6. So my new coefficients are 2, 7, 4, and 6. Now I know you're like, well, how does that work? I'll show you. Okay, so let's retally and make sure that it did work. 2 times 2 is 4 carbons. Okay, 2 times 6 is 12 hydrogens. And for oxygens, 7 times 2 is 14. Okay, let's check over here. We have 4 carbons here because of that new coefficient. We have 6 times 2, we have 12 hydrogens. And then for oxygens, we have 4 times 2, which is, I'm going to change this into an 8. Okay. And then 6 times 1, which is 6. Oh, what did I do wrong here? Oh, no, that's right, 14. Okay? So it works. You don't have to retally because you can rely that it worked. Okay? All right, let's try another one. So CHO, CHO, there's 7, there's 6, and now there are 2 sources of oxygen here, so I need to add them together. So there's 2 and 2, there are 4 here, and 1, 2, 3. Okay? All right, balance carbons first. The only thing I can do is put a 7 here, so that changes to a 7, and I'm going to get to my 6 by putting a 3 here. 3 times 2 gives me 6 hydrogens. So now let's see how many oxygens I'm working with on the right. So we have 7 times 2, so there's 14 right there, and then 3 times 1, which is 3. So 14 plus 3, 17. Okay, so this odd oxygen rule is going to come into play again. But before I can do that, notice that this hydrocarbon has some oxygens attached to it. You have to take that into account, because if you don't, you're going to end up with too many oxygens on the left. So before you place a number here, you have to subtract however many oxygens there are right here from this number. So 17 minus 2 is 15. It's still an odd number. So it's that odd number rule still comes into play. So I'm going to say 15. I'm going to plop that in like I did before in the previous example. And then I'm going to double everything else. So 1 times 2 is 2. 7 times 2 is 14. I'm just going to make this number bigger. Use that. 14. And 3 times 2, I'll turn this into a 6. Okay, and I'm not going to retally because I know that it works. So the coefficients are 2, 15, 14, and 6. Okay, feel free to retally and check that I'm right. All right, I'm going to do one more that has an oxygen in the hydrocarbons. CHO, CHO, there's 6, there's 12, and then 6 plus 2 is 8, and then 1, 2, 3. It's always going to be 1, 2, 3 on the right. All right, so let's change this. We'll put a 6 here. I now have 6. We need 12, so what times 2 will give me 12, and that's 6. Now I have 12. And now let's see how many oxygens I'm working with. So 6 times 2 gives me 12 on there, and 6 times 1 is 6. So we have 12 plus 6, which is 18. Okay, so there's no odd oxygen rule right now, but we do have to subtract out. There is an oxygen on this side. There's 6 actually. So 18 minus 6 means that there are 12. okay? So let me just back up again. So I first take the number that I have here on the right and I subtract out how many there are here on the left, okay? There aren't always, see, this one doesn't have an oxygen, so you don't have to do this step. But this one does. There are 6 of them. So 18 minus 6 is 12, okay? Which means I need 12 here. All right, so what times 2 will give me 12? Because this is not an odd number, I don't have to worry about putting the 12 there and doing that because that won't work, okay? All I have to say is what times 2 will give me 12, and hopefully you guys are like, well, 6 will, all right? So we have 1, 6, 6, 6, okay? And then everything else works out because you'll see that you have 12 plus 6 again, and that brings you back to 18. Okay, so that is combustion and polyatomic. Please let me know if you guys have any more questions. You can now try the practice ones first, the optional, and then do the Canvas. I am also going to post an optional video on how to do the shortcut without having to do all these tallies. If that is confusing, don't watch it. Okay, take care, guys.